Greetings, everyone. This is Eric Andelin, Senior Workflow Advisor with SimActive, and today we are interviewing Hayden Howard, Executive Vice President at CompassData, and Philipp Hummel, Vice President at CompassData. And our topic today will be GCPs for photogrammetry. How many do you need? Hayden, I'll start with you. Why don't you tell us about yourself and CompassData?
Eric, thanks for having us. Hayden Howard, Executive Vice President of CompassData. Been in the business for a long time. I think I watched a podcast of yours earlier today when you were talking about how you were surveying when you were a teenager, and I've been in the same boat. So grew up in this business, doing a lot of survey, got us into the drone space, have a lot of experience with remote sensing. Background is GIS and aviation meteorology from college, and just been a long time geospatial person.
Very good, very good. And Philip, give us some information about yourself.
Yes, first of all, thanks for having me on this podcast, and that I can be part of this, and I see what you're doing there. That's really awesome. Now, about myself, I grew up in Germany. I visited a university in Germany and got a master's degree in geodesy, land surveying, GIS, remote sensing, and photogrammetry, which is kind of a very unique education when you compare this where I'm working today, that this is kind of where the whole bandwidth is kind of really advantageous for me. So I did this in Germany, then I worked a little bit in Germany as a land surveyor in Africa. Then I came to the US. I worked for a regular traditional land surveying company. I became a PLS, professional licensed land surveyor in Colorado. And then I came to CompassData and I pursued to get more of that alphabet soup. And I did well. I'm licensed in a few states. I'm a certified federal surveyor and a certified photogrammetrist.
Fantastic. And what I really like about this is we're a company from Canada. Hayden and I are US. You're from Germany. Most of our customers from all over the world. So I really enjoy it when we have, a perspective from someone who's had an education outside of the US. For our viewers, I just want to let them know that I am thankful to Hayden and Philipp because about a year ago, they gave me a ride from the MAPS conference in Albuquerque to Pikes Peak and dropped me off so I could ride my bike up that mountain and down the other side. So they're happy to see I'm still here alive, right?
Yeah, absolutely. Good job.
Yes.
Happy to do that.
And honestly, part of that drive is what, made me think that we should have this conversation and share it with other people, because I learned a lot about what you guys are doing. And in general, surveying and photogrammetry, they're complementary to each other. They can be done separately, they can be done together, but together is usually the way to go. And both Philip and I have our certifications in photogrammetry, but as we know, we've got aerial mappers and now drone operators running all over the country, all over the world, collecting data. And we like to share our knowledge and help people out when it comes to how that data is collected and how you prove that that data is quality data. What we're going to talk about mainly are surveying, control, and ground control points as they relate to photogrammetry and aerial mapping. Specifically, the topics we're going to cover: placement and size. Why does it matter? Why is distribution important? How other technologies such as RTK and PPK play a role? And then, the big question is, how many control points do I need? You guys have more experience on the survey side. And Hayden, give everybody an overview of what Compass does, because we think of surveying and just in our heads, we think a fairly small thing or a fairly small area, couple acres, couple square miles, something like that. You guys do something on a bigger scale.
Yeah, for sure. So we're considered the control freaks. And that's kind of what our label is, but we've surveyed ground control for 30 years now. I think 1994 is when we got into the business. And so what we're out there doing is making sure that everything is super accurate with ground control for our customers. And we've since then moved into a space where we're providing control for our own internal divisions doing remote sensing, LiDAR, imagery, and all that kind of stuff. So we've got control points in over 100 countries around the globe. You can kind of think of us as the Indiana Jones of the geospatial world, right? And so we're traveling around and surveying all over the place and 70,000 points around the globe. So,
okay, so you don't actually get to go out and do that anymore, right? You get to send Philip.
Oh yes, there is once in a while a project that we definitely have our eyes on it. Yeah, but there was just an opportunity where I did not go out. There were two opportunities, one in Costa Rica, the other one in Hawaii. Really nice places to go. But then, of course, surveying in Pakistan and in other places around the world, it's not so easy. And we're really, really very lucky that we have our partners around the world that help us out with that.
Yeah, so that's maybe one thing that people don't know is that you don't necessarily go out and do all the work yourselves. You've got partners all over the world that collect the data per your specifications. As you said, you guys have got a huge database of control out there.
Correct. Yeah, we've got 70,000 points in those 30 years that I was mentioning earlier. That is also lined up with our partners that we have in different parts of the world. So, like, if we have work in Afghanistan or I don't know, these other crazy places that we go, we don't go there ourselves. We just have multiple partners in those areas. Then we send them information, trusted partners that we've worked with for years and years and years, good people. And they know how to collect to our specification. They give us the raw data, and then we do all the post-processing to our ISO and certified procedures. Yeah.
And again, we're not talking about small survey projects. You're collecting them for reuse. So how you collect them, what you do, and how you identify them is different than what the average person who's just doing a project, that's going to take a year, laying, fabric targets and so forth. You guys are kind of going for a little bit more solid point. Is that correct?
Yeah, that's correct. Yeah, we have to meet our customers' requirements, right? So sometimes they need us to go out and get specific features that they pick out. But a lot of times they say, okay, here's where we need to go, and it's satellite imagery, and it's kind of up to us to look at those features and see if they're going to work, and send them back to the customer, make sure that they're okay before we have our local surveyors go out and survey them, which sometimes can be a rock, corner of a fence, something that's not ideal, right?
Yep.
But it's in very remote areas, so that's how we worked it and been successful working that over the years. Yep.
And I guess the granularity of it has to do with what type of sensor you have, right?
Exactly. Yeah, absolutely. Yeah. Yep. It just totally depends on what kind of sensor is being used that we're rectifying, right? So satellite imagery, it's a bigger features that you can see. And then for drone imagery or aerial imagery or something like that, it's much smaller for sure. It's all based on the GSD of the image and what they need from that. Yeah.
Right. So maybe we could talk a little bit about, because we led into that placement and size of the control points. Philip, maybe a little bit of your comments on what you guys would typically do depending on the sensor or the altitude.
Yeah. So first, independent from the sensor, I would like to add there that an ideal ground control point is permanent. So anything out of concrete or asphalt that really we think like is much more permanent than white stripes on the street, a stop bar, for example. But the stop bar would be a really good example for visibility. There's a really strong contrast between white and dark. And so it will later show really well on the aerial imagery that was taken. When surveying then with GPS, it is important that you have like a good open sky view, that you don't interfere with the satellite signals. Therefore, you get higher accuracy or lower accuracy if it's like in a city canyon. These are like some some criteria, they're true for both if it's an aerial or a satellite collect. Now, when you have a satellite collect, and the older satellites, they had like 1 meter large pixels. It was really difficult to find ground control points of such large features. Ideally, a feature is about 2 or 3 times the GSD, so that the pixel bleeding that's happening then in the imagery, that it can be controlled and you can really click nicely on it as an operator. So with this rule of thumb, when you have then a drone flight that has only a 2-inch resolution, or even less than that, then you're looking at the possibility of choosing smaller features. And that would be then that you're creating small crosses or chevrons on the ground, or as you said it earlier, like a crack in the road. Now, it's a crack in the road is just not that permanent. And another rule of thumb I forgot was the repeatability. Imagine you want to go out there and check a point, or you have this project moving forward and your local surveyor is asking how to tie into this survey of yours. Then you want to leave like your footsteps so big that the next surveyor can step into it. That's kind of a borrowed saying, but you want to have like a nail or something to mark the center of those points.
Yeah, I noticed that sometimes when I've seen your guys' control and how you deliver it, and one of the things always impresses me is that you have photos of that point from different angles, so that the person who's going out to find that point knows exactly where to look. Because I'm sure you've run across it. Somebody will say, well, the control point's at the end of that chevron. Well, is it tip of the chevron? Is it inside the chevron? Where's it at exactly? With an aircraft, it might not matter, but with a drone and you've got that kind of accuracy, it's going to matter. And the other thing I was going to mention, and I'm sure you guys do this, everywhere I go, I see targets. Every highway, every sidewalk, I see targets all the time. And usually what I do is I look up and say, that's a worthwhile target or it's not. And you mentioned that you want to have a clear view of the sky for your target. Or your ground control point, and that is very true. Even more so, you have to have at least a clear view for the aircraft when it goes over, and it may be on a line parallel, but it still can see that target. And a lot of times I see that people that place targets don't necessarily take that into consideration, or maybe they have such a quantity of them that if they miss one or two because of building lean or something like that, that they have to discontinue using it. It drives me nuts when I see targets near trees.
Even more so with oblique imagery, when oblique imagery is taken, yeah.
So that's an excellent example, because we do see, or at least on our end, on the software side, we do see more oblique sensors coming out. So we've seen phase 1 obliques, small drone obliques, forward, backwards, left and right, 20 degrees. And yeah, that can really mess with the AT solution. I don't know. The next thing we would talk about is distribution. And this becomes, I don't know, a challenging topic. If you've got just a square project, it's fairly easy to define the distribution of targets given the terrain and vegetation and things like that. But if you've got a corridor or something that's not shaped where, how would you handle distribution? What would you say about that?
So I would like to discuss an AOI that is like a main area with a panhandle on it. Mm-hmm. Just think about the state of Oklahoma and you shrink it down to something smaller than an entire state. Then you have like this one large rectangle area, and then you also have a corridor that is attached to it. We see this actually in a lot of city surveys that happen where there's like, let's say, a water reservoir outside of the city or some other pertinent infrastructure, like whatever interstates going through. So that is a good example. And if we're looking now at the main body, I want you to imagine a pillow. And what you do is you stitch the pillow on the perimeter all the way around. And that's how it's a really good control. All these control points on the outside of the pillow, they have a really strong impact on the accuracy. The pillow will still buckle up in the middle or puff up, but you need fewer ground control points to stitch it down in the middle when you have a really solid frame going around it. So what's happening there on such a rectangle? When you look at the overlap with the images that are taken, you have like an overlap on an image that is on the inside. It has an overlap on all four sides. It has a forward lap to the front and to the back, a side lap to the left and to the right. So it's really tied into a whole fabric of images and tie points that the software will find. Along the edges of that pillow, the images have only 3 sides that they're tied in. There's just a forward and a backwards lap and a side lap to the left side, for example. So right there's the fabric less strong, and the extreme one is the 4 corners, where there's not so many image overlap. So everybody, when just by intuition, everybody would find the right solution to say like, oh, if you want to hang up a picture to the wall, you need 4 nails for the 4 corners to get it really flat against the wall. Now, traditionally, the recommendation is always to strengthen the perimeter, and then you need less points in the middle. So that is just like a simple rule of thumb. But this is like that main body. If we now look at the panhandle, we basically look just at perimeter, where there is no real body in the middle, and so the panhandle would use proportionally more GCPs than a large area. And like a panhandle, there are corridors that follow a gas pipeline or an overhead electric line or any other corridors. So ask me another question. I stuck you in a corner.
Well, I was going to say the other thing we need to take note of is that there are governing bodies or associations that have recommendations on placement and distribution of ground control points and checkpoints. Your local DOT may have those requirements, and those requirements may have been designed originally for full-size aircraft and then have gone through an iteration of being designed for mobile mapping, and now they're doing maybe possibly drone work with it. So sometimes the distribution doesn't make sense, but you know, that's the requirement.
The mix of all those sensors have basically brought it together that you want to have just an even distribution of GCPs. And that is kind of one thing that we see very often, that our customers come and have like different AOIs and they foremost evenly distribute GCPs. That is a very robust way of handling it. That's definitely a good way to do it as well. However, the larger the projects are, you have to split them down into AT processing blocks, and then that original idea that I said was the pillow to strengthen the perimeter. That's where you get the most bang for every GCP in accuracy in tying down a project.
Yeah, sometimes we have clients that know exactly what they want, Eric, and then there's other times where they don't know, and there's a lot of education there, right? And there's even projects that come up that, you know, they refer to certain specifications, but it doesn't fully align with what they, you know, what their project is, right? Like mobile mapping, you mentioned that earlier. There's a lot of stuff out there for mobile mapping that doesn't really have a very stern specification for how many control points. And if there is, it might be state to state. And then there's often the conversation of, okay, what's the professional judgment, right? Like how much do we actually need compared to what someone's telling us that we do need based on the specification. So.
Yeah, and we'll get into this the next thing, but technology changes that too. So the first mobile mapping systems that we had 12 years ago, something like that, when I was working with the DOT in Texas, helped them come up with their control diagrams, they were concerned about the tightest accuracy they could come up with and trying to match that value they could get in survey with the mobile LiDAR system. Now we have mobile LiDAR systems that are probably a bit more accurate and capture a lot more points. So that may change how many ground control points or the distribution you need now versus, back then.
Yeah, it's definitely a moving target for sure.
Yeah.
Right? Like, what's the distribution of base stations and the distance of base stations to whatever's correcting the position of whatever remote sensing vehicle that's out there. So, yeah.
Yeah. One thing I would say is that the IMU that is in a mobile LiDAR system, extremely precise. The IMU that is in a aircraft is extremely precise. The IMU that is in a drone is not. In most cases, is not.
Yeah.
So I always like to say, ground control is what will get you a solution, even if your IMU in your drone stops working. But that goes to the next topic, which is other technologies such as RTK and PPK. And I stopped being a surveyor a long time ago, 1987. I stopped being a surveyor. So that technology that's your range, Philip. Tell us a little bit about how those technologies would affect how you work with ground control.
That is right, but I can't help to say, like, 1887, Junge, you have been around for a long time, surveyor.
19, my friend.
Yeah, you said it right, but in the US, there's a lot of surveying that started somehow.
Yeah.
1887, when the surveyors walked across the prairie,
yeah.
and had a very different task than we have today.
Yeah.
So the extreme contrast is we're really blessed with a very good coverage of RTN networks that exist almost in every state. And I mean, there's networks, they really exist in every state. However, the density over the southwestern states or states like Montana and the Dakotas that are less populated, yes, there's not so much density, but we have a lot of really good coverage there. And that is very important to get to highly accurate GPS measurements, and therefore also to accurate GCPs. It shouldn't be underestimated the influence of baselines. Very often there are very long baselines involved, and I should warn everybody from very long baselines. It's kind of, the GPS reports more optimistically than the reality is likely to be. Do some check shots out there. Take an alternate shot with a static GPS measurement that's basically an alternative to the RTN based solution. Compare those two, and very quickly people can see what the difference is when you have very long baselines. So you should stay away from really long baselines. I say right now a number 30 kilometer, and the 30 kilometer is actually where the specification of Trimble or Leica equipment ends when you look at the spec sheet. 30 kilometers is only 20 miles. So very often we're finding ourselves more than 20 miles away from a base station. And there can be some compensation going on when you're within the whole network, when you covered on all sides with cost stations. But yeah, here in the West and the desert states or areas with lesser coverage, it's gonna get you lower accuracy on your GPS measurements than you would expect.
So if someone is out there flying with RTK or PPK enabled, and I don't know, maybe RTK has just been left behind, and you can explain to me, but what do they have to consider, as well as still GCPs, but what do they have to consider when they're going out to?
Drones come from different manufacturers, so it's hard to just say like, okay, there's one rule that rules them all. There's so many different manufacturers. For sure, you have to have your base stations close by. You obviously with a drone, you're not flying multiple square miles. You're flying a lot of acres within a square mile, so keep your base station close by. If you go out there and you use your system the first time, you better got a brand new system, brand new battery, everything works well. And then if you take the same system after you did 20 jobs like this out again, suddenly a battery might fail or whatnot. And as soon as it starts failing on your base station, the whole trick doesn't work anymore. So be prepared for that.
So for those people that are going out, and I don't know if you hear this, we hear this a lot on our side. The answer is, well, I have PPK and the PPK is right, so there's something wrong with the ground control. You hear that a lot. There's a lot more involved. I guess that's all I could, in my opinion, there's a lot more involved in how you got your PPK solution than there is in what the surveyor did with the ground control. And I don't know of any legal situation where somebody's going to accept somebody's PPK derived result from a drone versus somebody who's got actual ground control. Can you give a couple comments to that?
Yeah, I mean, I can open it up, Philip, you can take it from there, but there's Geodesy, right? And there's Datum's Epics. Like if you're just somebody out there as a recreational user of a drone and you go and you follow the manual and click the buttons and fly it, you can get imagery and you can get accurate imagery, but what's that accurate to? Right? You might have a customer that's on a local mine site, for example, or some version of NAD 27, right? Or something really different than what you just get off of the controller. And that's a big part of why we're around and are still around, is because we really understand that stuff. Like there's velocities that, I mean, everything's moving all the time, right? Plate tectonics, all that kind of stuff. So taking that into account and really understanding what the customer's accuracy and datum and all the requirements, that's huge. It's a big part of what we do every day. And Philip is geodesist, so he can expand on that.
I'm not going to lay hard into that. Yeah. Thanks for setting that trap up. Be conservative out there. Do conservative things. When you're trying to get it cheaply done, imagine how expensive it's going to be to get back there a second time and doing it again. So coming from the surveying profession, there's a reason that surveyors do checks all the time. And so many times a surveyor is just frustrated out there because his check doesn't work. And poke a little bit around in your software and you find probably the reason why it didn't work today, what worked yesterday. There's a lot to it. Now, what we haven't mentioned yet, and I want to say this, there is project pressure. And there is like a request from a customer and they don't have the time to wait until you have the final orbits, the best ephemerate data, to correct your data and basically wait another 6 weeks before you deliver, simply because there's some project pressure. And that means you go out there today and tomorrow you have to start processing. They have to extract maybe some vector data, or the survey department is waiting to add the culverts that they surveyed, the boundary points. So there's so much project pressure almost with every project that there's not the luxury of waiting for 6 weeks to have like the final orbits for GPS processing to download. And yes, there are exceptions, but I wouldn't even start really making a field plan that banks on that there is time for 6 weeks to get final orbits.
Yeah, and we are starting to talk about high accuracy results, but as you said, you've already got project surveyors out there. They may be doing culverts, they may be doing shots and things like that. While they're out there, shouldn't they be out there, setting up some targets for these folks?
I think most people do this by now.
Yeah,
I would guess that 10 years ago when the first drones were out and then this whole thing took off, there were like a lot of one-man crews that can do it all. And well, they can do what they're doing. There's a lot of really talented people out there. I don't want to take from anybody's anything away. However, the survey profession, when you're talking accuracy and you want to achieve a really high accuracy, you have to get this integrated with all the other land surveys out there. You want to have an integration with an NGS monument, either it's a passive or an active one. Potentially, you're working on a mine site where there's a mining coordinate system, as a local coordinate system that is set to be on ground and no longer on grid. There's so many moving pieces out there. You gotta, it's the profession.
Ground
People
and
know.
grid alone will just scramble people's brains.
Well,
oh, it did mine too. Don't.
Yeah, absolutely. Yeah, so I certainly agree with that. And then, the last thing that maybe we could chat about is a little bit is everybody wants to know how many ground control points they need given a specific project. And there really is no rule of thumb, is there?
So I would like you to look at it the perspective of the person that works downstream. So imagine you're working potentially in the CAD drafting department, or you're working at processing the imagery. Then there is you have a drone pilot out there, and you have a surveyor out there. The surveyor that does ground control points, in this case, is potentially the first one out there. Then comes the person who flies the drone or the aircraft. This might be a subcontractor, and at some point it will land on somebody's desk downstream. Now, if this person is sitting there and has, instead of 100 points that are like adequate for the size, has only 90, or alternatively has 110, all of these professionals will say, I prefer 110. I always want to have 10% more of it. Of course, this costs 10% more of the field time that's out there, but it doesn't cost more in the mobilization time or in the processing time. So while you're out there, be nice to those guys that have to work with what you collect today and collect 10% more of everything, so that they can make a solid product that is robust enough to handle a few exemptions. If you have 10% too few points, and we spoke about this recently, when it's like a satellite project that has a satellite scene of 10 by 10 kilometers, and there were like 4 points surveyed in the corner that were considered sufficient of this. You can always balance this satellite scene on 3 of the points. It's like a table where there's one leg too short. I mean, it wobbles in 2 ways, that table, and you have no way of finding out which is your tiebreaker, which is the one that is the correct one, and which one is the incorrect. Now with with aerial triangulation, where there's more GCPs, and then in that case with the satellite data, it's probably not like a 4-legged table anymore. It's more stable. But as soon as you have these panhandles attached to it, it's going to be difficult there. Now, still, I haven't answered even your question. I have just put a bunch of warnings out there and consideration and being like a considerate, nice person to others. But the requirement will depend on a few parameters. Number one is the hardware that is used to collect the aerial data. Is it whatever LiDAR systems come in different qualities. So do photogrammetric cameras. There's the metric side of it, and then there's the drone cameras of it. Then it depends on the size of the area and the expected accuracy that the final product has to have. So there's so many different parameters that it's also fair enough for me to say, like, yes, 100 is the correct answer.
Well, I remember in the late 80s when we would do corridor work for Caltrans,
Yep.
you had to have a control point every other model. So that was the rule, just because they weren't so confident in AT solutions back then, maybe, or they just that's the way they decided that it would be. Today, it's certainly overkill on a drone. You would flood the field with control points because of the footprint of the image. But I think just in general, we've been able to reach farther in the AT process, in images or models, spread that distance of control out.
Yeah, I guess one thing I'd say is like the requirements that get put down on us for the most part, as we're a third-party accuracy verification company, like we do other things, obviously, but when it comes to that, like you just had third-party verification, it's more on the number of control points or checkpoints rather that are required based on some standard that's out there, right? So if we go do a county in Michigan or some place like that, it's known, right? You can go look at a standard and say this is the number of checkpoints are, and then the number of control points that are needed, which are done by us a lot of times. Like it's just whatever the flyer says that they need, right? And then it's either enough or it's not enough.
Yeah, and these things change because right now, for example, here in the States, the ASPRS is going through an update of their standards that includes this.
Yeah, yeah.
Did you have anything to do with that, Philip?
Not directly. Indirectly, I have been in the presentations, and I know the responsible people, I should say, and I talked to them. I have reviewed it and basically given my review of it, the peer review, but I have not been at the design.
Were you part of it, Eric?
Yeah, I was involved, same as Philip, a little bit more on the review side. There were keywords in there that I didn't like. Well, I mean, to the best of your abilities, you guys have answered my questions and provided some entertainment for us. So I'd certainly like to thank you guys for your time. For those that would like more information about CompassData and all the things that they do, we'll provide that. Hayden and Philip, thank you very much.
Yes. Thank you, Eric. I want to just make a shout out here to our team at CompassData, because we have professionals that work basically day in, day out in surveying ground control points. We have our ground control point archive. So we have something where we have stored all the ground control points. Hayden mentioned it earlier, 70,000 around the world. The majority of those points is in the US. So this data is available off the shelf and can support all of the projects out there. In any case that somebody goes out there, finds out they have too few GCPs surveyed, or they think, hey, we don't even want to survey GCPs, there is an archive. Look there first, and if you have a problem with your product, we can help you and test it and do like an independent check, take our independent points, throw it on your project and tell you afterwards how good or bad it looks like. So I think I used up my credits to make this call.
No, you're absolutely right. You guys have a database of control points out there. And again, they're photo identifiable and they're well documented. So if your project, and you can search these through website or a KMZ file, but if your project has one of those points in there, you can either add it into the solution or you can use it as a check, see how you're doing. And I think that's fantastic. It's not going to work for everybody, but it may. So it's before you hang it up and say I have to send more surveyors out. Yes, I didn't get that extra 10%. You could at least check and see what's out there. Again, thanks guys for your time.
Save your soul with ground control.
All right. That's it for the control freaks. Thanks, guys. For those of you that are not familiar with Correlated 3D, I'm going to go ahead and pop into a little bit of a demo here. All right, so let's start a project. we'll go ahead and load some imagery. So we'll add a folder and we'll say in here, imagery. And the projection is 2237. Yep, 2237. Camera information is already there. So we'll create a project folder. And we'll just leave it in this new folder. Yep. GCP file. Now we can add it here, import. And let's see, we've got one right here. And we just need to assign these values. Now, of course, we can change the projection. We can make them just Z value GCPs, XY value GCPs, X, Y, and Z, which is what we're going to do. And then also we could assign them as checkpoints. Now, we can also do this later on in the process. So bear with me. So first I will give them their correct columns. And we hit import, hit finish. And now we have the flight lines and the control in the project. So this is the first way you can bring control into Correlator 3D. There are two more ways to do this, so let's move on to the next one. So taking a look at the completed project, I want to show you how we can add control points once the project has been started. So I showed you how to bring them in at project initiation. Let me show you how to bring them in once the project started. So let's go ahead and turn off some of this stuff so it's easier to see. We'll turn off the links and everything here. And we'll go ahead and turn off the ground control that already exists in there. So what you would do is go here again, import GCP file, and this is in the AT module. You would select that file, which again is here. And then same options. You can change the projection. You can change it from GCP to one of the other values. And again, you would assign them 1, 2, in the order that they belong. And here it says add to existing GCPs because there actually are, this is a duplicate set. So then you would just hit import and those GCPs would be imported. So you have that ability as well. And then lastly, I want to show you if you wanted to create a GCP. Let's look at how that would be done. Okay, so the last option is when we want to create our own GCPs. Now, there's a couple of things you can do here. Obviously, if you want a GCP that's XY, then you're going to want a good reference image. So for example, this is just Google Earth. That's not going to work. However, I do have the mosaic that we created, and I could use that. Also, you're going to want to extract those GCPs from a surface, a reference surface that you brought in. If you select, for example, a surface that was created from LiDAR, you just bring that in. Then you can create a GCP, and it's kind of an independent of Correlated 3D. So we can go in and, for example, I will pick an area to zoom in. Let's say right here. And we want to create our own new GCP. So again, we're using a surface that was not created or in Correlated 3D, we just added it. And we'll go GCP creation. And we'll go, for example, over here to this corner. Now, because we know that Correlated 3D has already created a good mosaic, and that these images are kind of roughly tied together, we could do this as a total GCP, X, Y, and Z. But, just for an example, if you weren't confident in your reference image, or you didn't have a mosaic that was already created, you could just go in and do a rough and use the elevation and not the horizontal value. So you would just go in here and select, again, from the images and go through each one. And it's going to pull a Z value, again, from the reference image. So I will save and close GCP Z, It's pulling that Z value from there. You can save it and close it. Now, you can add that in to another iteration of AT if you would like. All you have to do is rerun the AT. So there's 3 ways you can do this in Correlated 3D. You can import the GCP file when you create the project. You can import the GCP file after you've created the project in the AT, which you would do right here. And then lastly, if you wanted to create supplemental GCPs, my recommendation would be to bring in a unrelated surface of the same type of accuracy, and you can create your own GCPs in this function. Then you can bring those back into the AT and see how they fit. So it's a good way to, say, check a LiDAR data set that is in the area. If you don't have ground control to work with, then you can pull it from that LiDAR data set and a good reference image, or you could at least pull Z values. You could also bring in a existing set of GCPs, again, from somebody, a third party like CompassData, where they've already got GCPs in the area. You just download that GCP and bring it into here. And again, you can use that as a check. So don't forget that as well. I hope you enjoyed the tutorial. I hope you enjoyed the interview. If you have any questions, please reach out to us. We're more than happy to help out. Remember, this interview, our webinars, our podcasts, and our tutorials are all available on our website, simactive.com, under the Learning tab. Once again, I'd like to thank my guests, Hayden and Philipp, and those of you for joining us. Until next time, thank you.